we have a standard xy coordinate plane, and I'm given coordinate points for A and C. And I've already written those in red and blue. And what we need to do is find B. So what we know is that B is collinear with A and C, meaning it's on the same line. So let's draw a line between A and C. That's not bad. And B is somewhere on this line between A and C. Okay, so that's helpful, but there's still a lot of places between B and C where I could put it. So I'm going to need to use this information about the ratio of their lengths. AB compared to BC is in a ratio of 2 to 1. That means the AB portion is twice as big as the BC portion, meaning I should draw it something like this. I don't know if that's exactly right, but if you look at this, that's about 2, that's about 1. I think that's about twice as long. It's not perfectly accurate. And by the way, these aren't lengths of 2 and 1, right? I don't think that would be long enough. It could be 20 and 10 for all I know. The important part is that the ratios are 2 to 1. Okay, so if that's approximately where B is, let's figure out the coordinate points of that. And there's the long way and the short way. You're in a timed test, so let's do the short way. And if you want to stick around for the long way, by all means. The short way is, what's the y-coordinate of B? Well, it looks negative. And some of these answers are positive. So knock those ones out. It's not going to be the positive ones. Now, you've got it down to a 50-50 guess. That's already pretty good. And we can do even better than that. Because look at this. There's -1, and there's -5. And only one of those is between A and C. So we're going to pick this guy right here, just based on an approximate coloring of the graph. Now, in terms of where the B coordinate is located exactly, I'm going to go through that now. And if you want to check out, that's fine. But it's kind of interesting the way this works. I'm going to take that ratio again, and I'm going to say this distance, AB, is equal to something compared to AC, the total length of the line. And the way that's related is by a fraction of 2/3. Now, if you're wondering why that is, remember how these ratios looked. It was 2 to 1. Well, that's a total length of 3, which means the AB portion of it is like 2 out of 3. That's a ratio of 2/3 right there. So, great. We've got this equation. Let's turn this into something useful. I'm going to stick to the y-coordinates that I was talking about. That means the y-coordinate of B minus the y-coordinate of A, right? The ending point minus the starting point, that distance is equal to 2/3 of the c-coordinate in y, the ending point, minus the starting point in y. And now we just plug in numbers. So I don't know what by is. We'll leave that alone. But I do know that ay is 3. And there's my 2/3, and I know that cy is -3, and I know that ay is 3. So now we just work through the equation. by minus 3 equals 2/3 times -6. Some more simplification leads me to this, by minus 3. I haven't changed the left side, but the right side is -4 now. And I'm going to add 3 to each side, which gives me by equals -1. Okay, great. Now I'm sure that I'm right. And if you wanted to do this for x, because you're just having so much fun, no problem. Set up your equation this way. Bx minus ax equals 2/3 times cx minus ax. Now you plug in those coordinates again. Solve this for b of x. You're going to get 6. And I'll leave that as a little exercise for you to do on your own.